Good morning, class, or afternoon, or evening, depending on when you're watching this. Miss Neely's taking a break today, so I'm going to actually be doing the whole thing. Let's take a look at page 31. If you want to go ahead and turn in your book to page 31 to take notes and follow along. The last section had to do with kind of adding and subtracting some of the monomials. Today we're going to actually look at powers with the monomials, which works a little bit differently than than how you're doing the exponents before. So right here at problem 1, it says the Marine Club at Westview Middle School purchased an aquarium. The aquarium is in the shape of a cube with a side length of 2 to the 4th power inches. So that's going to be an important piece of information. Feel free to underline it if you want. Use the questions to find the amount of water the aquarium will hold. So we know it's 2 to the 4th power inches. Now please, once again, that is not meaning 2 times 4. It's not, 8 inches for the length. It's 2 times 2 times 2 times 2. It's 2 being multiplied together 4 times, okay? So it says number 1, write a multiplication expression to represent the volume of the aquarium. So the volume of the aquarium, well, we know it's a cube. We know we're finding volume. So we know the length is 2 to the 4th power. Well, what do we know about a cube? What do we know about the sides? Well, a cube is basically just a 3D square, a 3-dimensional square. And we know the square, all the sides are the same. Okay? So we know to find volume of a cube, we have to use the formula V equals length times width times height, which is sometimes used for like a rectangular prism, which a cube is, or a cube has a very special formula because all 3 sides are the same. You will often see for the volume of a cube, we'll use this formula, V equals, and some people put L for length, some people put S for side. I typically do S for side to the 3rd power because it's that same side 3 times, which is basically this here because your length, width, and height are all the same in a cube. So whatever the side that it gives you is, you'll have 3 times just like you do there, since all the sides are the same. So to write an expression for that, you just take the length, the one side you know, which is right there. Then you know your width and height are the same. So we just fill those in right there, multiply them all by each other, and it's the same thing as just taking S, the side that we have right there, to the 3rd power. Okay? It says simplify the expression. Right is a single power of 2. So here we have bases of 2. We have then the exponents all with 4. And so basically we just can put those together. 4 plus 4 is 8, plus 4 more is 12. So we know we have 2 to the power of 12 as a simplified expression. Okay? Now using 2 to the 4th power as the base, write the multiplication expression 2 to the 4th times 2 to the 4th times 2 to the 4th using exponents. So another way to do this, and this goes back up to this formula. This one's kind of connected there. This one's more connected here because we're going to take 2 to the 4th, which is our side that we have, and then we're going to raise that to the 3rd power. Okay? So basically we have 2 different ways to write this, and the book here is just showing you essentially both ways. Now, explain why 2 to the 4th, all then raised to the 3rd power, equals this. Well, basically what you saw here is that this here, if we were to multiply all of this out, we know that one of these 2's to the 4th power is basically like 4 2's. So we have 4 2's, then here we have 4 2's, and then here we have 4 2's for a total of 12 2's, all being multiplied together. So that's how we get 2 to the 12th power right there, because if we, like I said, if we listed it all out, we'd have 12 2's. Here, this being raised, these are the same because in this scenario, if you have a power raised to another power, you end up multiplying those numbers together. Okay, notice there's no base in between these. If you have bases in between, you add. If there's no bases in between, you just have a power or an exponent to another exponent, power to another power, depending on how you want to say that. You actually end up multiplying, which is what we have right there. So however you choose to explain that, you can. It says use a calculator to find the volume of the tank. So here I just can take 2 to the 12th power, or in your calculator you can do 2 to the 4th power and then take that to the 3rd power. I would recommend doing that both ways just so you have an idea of exactly how that works, and you should get the exact same number, which should be 4,096. Okay? So please remember that these actually equal each other. That's connected through there, and then this is connected through there, but ultimately whichever way you choose to do it, you should end up with the exact same answer. Now we're actually not going to bother with numbers 6 and 7 on that page. We're going to go ahead and flip to the next page. So now go to page 32. It says a power of a power at the top here. There it is. It says 5 to the 2nd power, then that being raised to the 3rd power, equals the 5 to the 2nd times the 3rd. 2 times 3 is 6, so that one's just 5 to the 6. Okay? So once again, if we have multiple bases here, these are all the same. All these 6s are the same. Okay? If we were to basically have this 5 different times, we'd see 1, 2, 3, 4, 5, 6 to the 4th power. Okay? Which then, if we added up all these, because now we have bases in between the exponents. Okay? We have bases in between. So if we have bases in between, we add. So 4 plus 4 plus 4 plus 4 plus 4. That gets us to 20. All right? Or a quicker way to do it, if you see that this is raised to the 4th power and that's raised to the 5th power, 4 times 5 is also 20. Either way, you should be getting right here. Okay? Let's take a look at something out to the side here. So I'm going to use the example of, we'll just use 3 to the 5th power all the way to the 2nd power. Okay? So basically I have 3 to the 5th twice right there, which I could then write out if I really wanted to just torture myself, which apparently I am in for. I can write a bunch of 3 to the 5th. So here I have a 3 to the 5th. Okay? Oh, I messed up there. Need to get rid of these. Okay? I have 5 3s, 1, 2, 3, 4, and 5. But then I have it again, 1, 2, 3, 4, 5. If I count up all those 3s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I have 10 3s all being multiplied together. Okay? Which you should know by now would be 3 to the 10th power. Okay? Now that's just torturing yourself to write all that out. A much quicker way to do that is to recognize 3 is to the 5th power. If you don't have a base in between the next power, you multiply those. 5 times 2 is 10 right there. So a quicker way to do it is just to have 3 to the 10th power. Okay? So that should make pretty good sense. If you need to, feel free to watch that portion again. So simplify using the law of exponents. This should go pretty quick for you. You have 8 to the 4th power, no bases in between, so we multiply. 4 times 3 is 12. You have 8 to the 12th power. Now what if we have a variable? Once again, a variable is just a letter that takes the place of an unknown number, or sometimes a known number, just kind of depending. So we have k, a variable, some unknown amount to the 7th power. Now notice, is there any base in between that and the 5? No, so we simply multiply together. 7 times 5, 35. We have k to the 35th power. Alrighty. Now out to the side, what Miss Neely and I want you guys to do is to actually work out number 1, and I'm going to help you here with number 2. Do that one yourself, fill that in. Number 2 here. Once again, we have a variable, just like we did there. 4w to the 4th power no base in between, so we multiply 4 times 6. You should have w to the 24th power. Right there. Now this one is trickier because you have a power being raised to a power. Oh, you can't see that on yours. There we go. C is a little bit trickier because we have a power being raised to a power being raised to a power. Don't let that throw you off, okay? Don't get scared. Don't wet your pants. Don't go cry. No need for that. All you got to do is follow the same rules. Just keep multiplying things together. So we have 3 to the second being raised to the third being raised to the second. 2 times 3 is 6. 6 times 2 is 12. So 3 to the 12th power. And write that right out to the side where I have it right there. Okay, now go to the next page, page 33. Okay. Power of a product. To find the power of a product, find the power of each factor and then multiply. Now this one uses the same idea as before, except we're throwing in some more numbers at the front. So if you look here, previously we basically had a to the second power to the 5th power. Now we're adding a coefficient right in front of that, okay? So we're taking this whole thing 5 times. And in order to do this successfully, you kind of have to break it into its different parts. Okay, we're going to have this 3 5 different times, okay? This 3 is going to occur 5 different times. And then the a squared is going to occur 5 different times because it's being raised to the 5th power. So if you wanted to list it all out, you would just have 5 of these. Then we have to break it into its different parts. Right here, we have 5 3's all being multiplied together, which are going to get us 3 to the 5th power. Then here, we have 5 a squareds all together, which is going to get us a squared to the 5th power. Then to multiply this out, we always want to multiply the coefficient number when it's out in front of these. So 3 to the 5th power is 3 times 3 times 3 times 3 times 3, which gets us 243. And then a squared, then to the 5th power, no base in between, so we do 2 times 5 and gets us 10. So our answer then would be putting these two things together. So we have 243 times a to the 10th power. Now one way I've taught kids to think about this, and I'll show you here on example 3, is anything that does not have a power, I sometimes put a 1 by. So if we look at example 3 here, and I have 4p to the 3rd power, that 4 has no exponent with it. So I would actually put a 1 right there. Okay, sometimes I draw on a 1. You don't have to do it this way, it's just a little trick. So then when I multiply this out, I know right away I'm going to have 4 to the 1st power. That gets multiplied by that. 1 times 4 is 4, so I know I have 4 to the 4th power. Then p is to the 3rd power, no base in between. So 3 times 4 is 12, right there. So that gets me my 12 that I get right there. So you have 4 to the 4th power, you have 256 times p to the 12th. Okay? 4 gets a little bit more complicated, but not too scary if you're paying attention. Once again, we're going to break this out and do all of its different parts. Notice, I'm going to look for powers here, or exponents. So I have m to the 7th, n to the 6th. My -2 has nothing. Okay? So I'm going to put a little 1 right there. So when I break this all apart, I'm going to have -2, 1 times 5. I'm going to have 5 of those, times my m, 7 times 5 is 35. Then n to the 6, 6 times 5 is 30, so I'm going to have n right there. Okay? Now I'm going to multiply this all out. 2 times 2 times 2 times 2 times 2, 5 times, will get me 32. So that's where I get that right there. Don't forget your negative out front, so I have -32, m to the 35th, n to the 30th. Okay? Now, I want you in your notes to do D by yourself and put it out to the side. And then we're going to work out actually F right here. So once again, My negative 5, I'm going to put a little 1 there so I can multiply. So I know I'm going to have negative 5. 1 times 3 is 3. W squared, so 2 times 3 is 6. Z to the 8, 8 times 3 is 24. Right there. Now we always multiply this part out here. So 5 times 5 times 5 gives me 125. W to the 6th, Z to the 24th, and don't forget your negative out front. Okay? So I want you to do D and E on your own. Put those answers out to the side. Go over this. Anything you need to watch again, feel free to do so. We'll see you guys tomorrow.